So we're supposed to be done with part 3, 22, 23 sabi dito, but I can make it faster later next time. Kasi yung part naman yan is describe the concept of solubility. Okay. So today what we're going to do is this part doon sa acid base. So if you're going to look at this, yung describe the acid, systematic approaches of acid base, perform pH calculation, strong and weak acid bases, and then describe buffer solution and its components. So yun yung tatapusin natin ngayon with following this thing. And I would also suggest you watch this, what we call material that you have here, although I'm going to tackle most of them. So just to tell you, this is, oh, ito na naman commercial na to. So this is what you have. But I'm going to what we call finish this thing, like what I did earlier. Okay. Usually in second class, mas mabilis kaysa sa first class. So we just finished, okay, before you log in. Okay. So I want you to look at it and then, yeah, let's start with, nasaan na yun? Share. You share. Okay, so let's go to the definition of acids and bases. Because yun yung first ano doon, yung tinatawag nating learning outcomes. Okay, of the acids and bases. The first learning outcome describes acids and bases, specifically using the Bronsted-Lowry definition. Okay, but before we go to that part, so usually acids, these are the one that has what we call sour taste. The vinegar owes its taste to acetic acid, and the citrus fruit contains this what we call citric acid, di ba? Kapag pinawisan tayo, sabi natin ang asim ng amoy mo. Okay? So most of the acid, they will react with metals to produce hydrogen gas. The exception that you have here is the noble metals. So noble metals, those are in the jewelry like gold, silver, and platinum. They don't react with acids. That's why one way to test, I don't know if you look at some of the trade there. So usually they said, oh, pure gold. Tapos inaano nila doon sa parang kalamansi or vinegar. Tapos kapag nag-corrode, peke yung kalamansi o vinegar. But the thing is, if it's pure gold or pure noble metal, it will not react with the acid. So acid will react with carbonates and bicarbonates to produce CO2 gas. So the classic example here is the volcanic eruption. You have baking soda and vinegar. So you will see like the volcano that's formed there. The gas, there's the CO2 that's formed. Okay. Now bases, on the other hand, they have a bitter taste and a slippery feeling and usually used as cleaning material. So the definition of acid and base, before we concentrate on Bronsted-Lowry, we could say, dun muna kay Arrhenius. Svante Arrhenius, as part of his dissertation, defined the concept of acid and base. Okay. So he defined acid as substances that produce H plus or H3O plus. So H3O plus is just H plus water. Base is anyone that produces hydroxide. So the committee doesn't understand what it means. He gave it the minimum passing grade, and 20 years later, he got the Nobel Prize for the definition of these ionic compounds that form in solution. Okay. Now, the problem with Arrhenius' definition, it limits the hydroxide to hydroxide-containing group. Ammonia cannot be classified as Arrhenius base. So independently, Johannes Bronsted and Thomas Lowry define acid as a proton donor and base as a proton acceptor. Madaming pwedeng pagbuhaan ng question dito sa exam. Okay? And Lewis acid, Lewis is the name of what? Gilbert Lewis, the Lewis symbol, the Lewis structure. So here he defined it as anyone that can accept an electron pair, and a base is anyone that can donate an electron pair. So if you're going to look at, there's also a limitation of the Lewis acid and base. It's only applicable if you have the electron pair. So if you're a base, you're an electron pair donor. If you're an acid, you are an electron pair acceptor. So the one that we're going to focus on is the Bronsted-Lowry, or this one we call the Bronsted acid. I'm using Chang, but other book says there's a Bronsted-Lowry. Okay, so Bronsted-Lowry acid, that's a proton donor. Bronsted base is a proton acceptor, or we could say the acid base is just what? Proton transfer. Proton is what here? Ano yung proton? Anyone? The H plus. Now, synonymous to the Bronsted-Lowry acid base definition is yung tinatawag nating conjugate acid base pair. Okay? So, anong ibig sabihin nitong conjugate acid base pair? So, if your acid on one side, that species will become base on the other side and vice versa. So, for instance, if you have ammonia reacting with water, so one of them will act as an acid, one of them will act as a base. So the acid that acts here, okay, it will lose hydrogen, resulting to the formation of its conjugate base. The base that acts here will accept the acid, resulting to the formation of its conjugate acid. And to determine which one is the acid and base on both sides, or on this other side, you have to react this like an acid-base reaction. And the one that gives here, the one that gives the hydrogen or the proton, that's the acid, and the one that accepts the hydrogen or the proton, that's the base. So between the two here, alin yung acid, water and ammonia? Class?
Ammonia.
Ammonia.
Which is the acid here?
Ammonia.
Ammonia ba? Alin yung nawala ng hydrogen? Remember, proton donor. Okay.
H2O po.
So water lost the hydrogen. So that's the one that donates its proton. And the base accept. Now, how do we know? Here. So it lost the hydrogen. Now, if this reacts, okay, so this will gain a hydrogen to become water, and this will lose a hydrogen to become NH3. So we could say on this side, ammonium ion is the acid, hydroxide ion is the base. Or if we're going to define it in an acid-base pair, hydroxide is the conjugate base of water, ammonium ion is the conjugate acid. So what's the difference of the conjugate base and the conjugate acid? It's usually one more or one less hydrogen, right? If you're a conjugate base, you're what? One more, one less hydrogen?
One less po.
One less. And if you are a conjugate acid, you are one more. Because I can ask you here, what is the conjugate base of H2O? Or what is the conjugate acid? Kasi conjugate base pala yung sagot dito eh. So what is the conjugate acid of H2O?
H3O.
H3O plus.
Yes.
Because you are adding an H plus. Okay? So ganun yung conjugate acid base pair. So if you are asked what's the conjugate acid of the other one, you just add an H plus. If you're asked what's the conjugate base of the other one, you just remove it with an H plus. Now, some can act as an acid and a base, just like water. And you call this amphiprotic substance or amphoteric substance. So amphiprotic or amphoteric, they can act as an acid or a base, depending on what the other species is. Okay? So we're done with the nature of acids and bases. The next that we think we do is water. What is unique with water? Bakit unique yung water? Because it is known as the universal solvent. They said Earth is alive because of the presence of water. Okay. Now, what makes water unique is it has both the acidic and the basic property. Water can act as an acid or a base. So if you react one water molecule with another water molecule, one of them will act as an acid and one of them will act as a base. So the acid, okay, will produce the conjugate base and the base will produce the conjugate acid. Like this. Or the water can just auto-ionize to produce an acid and a base. H plus and OH minus. So that's what makes water unique. Okay? Now, if we're going to write to here, this acid will act, this water will act as an acid and the OH minus is the conjugate base. The other water will act as a base and its conjugate acid is H3O plus. So if we're going to look at the reaction of water, it produces ion, right? H plus and OH minus. So what do we know from our expression? Do we really need to include H2O? No. So if we don't include that, because that's a constant, we can incorporate it with Kc. So Kc times Kw, it gives Kc times water will give you Kw, which is that just the ion product constant. And it is the ion product of H plus and OH minus at a particular temperature. At 25 degrees Celsius, it is 1.0 times 10 to the negative 14. So what makes this unique? What makes this value unique? Well, you can get the relationship between the concentration of the two species, the OH minus and the H3O plus, the H3O plus or H plus. If they're equal, the solution is neutral. If H plus is more than OH minus, it is acidic. And if the H plus is less than the OH minus, it is basic. Okay? Questions of our class? Better now. Oh, shit. Very good. Okay. Let's do some sample calculation. So we see here, Kw is just equals to H plus times OH minus. So let's have this problem solving. What is the concentration of OH minus in an HCl solution whose hydrogen ion concentration is 1.3 times 10 to the negative, 1.3 molar? How do we solve that? Kw equals to plus Andiyan ba kayo? Hello?
Over HCl.
So if we have this one, we just divide this by, right? Kasi ang hinahanap natin ay OH. And you have 1 times 10 to the negative 14 divided by 1.3. So ano yung OH minus nyo? That's the answer. So, kaya ako ng ano, something. So, since you have two significant figures that's given, you also write two significant figures. So this is what, 7.7 times 10 to the negative 15. Right? Kaya? So far, so good.
Excuse me po,
Next,
sir.
yeah.
Bali po, sir, hindi na po kailangan gamitin yung HCl sa pagsosolve. Or,
Ano mangyari sa HCl? So usually, we dissociate siya to H plus and Cl minus. Kung ano yung 1.3, yun din yung 1.3. Tama?
yes po, sir. Thank you po.
Ayos? Okay lang?
Yes po.
So, ang relationship kasi KW, H plus, H minus. So, kung meron ka na dito 1.3, ano yun nandito? At meron kang value na 10 to 14. Now, let's go to the pH. The definition of pH, the power of the hydrogen. So pH is just defined as negative log of H plus. And if you have that, you can determine the nature of your solution. So when a solution is neutral, there's equal concentration of H plus and OH minus. And the pH and the concentration is usually around 1 times 10 to the negative 7. And if you're going to get negative log of 1 times 10 to the negative 7, that is a pH equals to 7. If it's acidic, your H plus is more than your OH minus. Okay? And your H plus is more than 1 times 10 to the negative 7. So your pH is lower than 7. And if it's basic, the H plus is less than the OH minus, and the H plus is less than 1 times 10 to the negative 7, and the pH is higher. So if you're going to look at the relationship between the two, it's a seesaw relationship. As the pH increases, the H plus decreases. As the pH decreases, the H plus increases. So at low pH, that means you have higher concentration of H plus. At high pH, you have lower concentration of H plus. Clear ba yun? Ras?
Yes po.
Yes po.
Yes po.
Kasi yan
Yes
yung mga
po.
concept question na pwedeng tanungin sa inyo. So I don't know how you find the exam. Totoo ba yung sinabi ko na yung lahat ng question, makikita yung sagot sa module. Okay? Now, if we can define pH as negative log of H plus, so if we're going to replace this H plus with what? OH minus, meron din siyang corresponding expression. And that is what? POH. So POH is just equals to what? Negative log of OH minus. Remember, the species that you have water is either H plus or OH minus. Okay? And we know from the initial slide, H plus times OH minus will give you what? A KW value of 1 times 10 to the negative 4. Paano kapag ginawa natin negative log mga yan? So negative log of H plus minus negative log of OH minus equals to 14. And ano yung definition natin ng negative log at negative log nito? It's just the pH and the POH. So if we add them, that is equals to 14. Now to give you the corresponding pH value, you can see here, some. So ano masasabi nyo? Yung mga acidic, ano yung mga yun?
Juice.
Lahat sila pagkain, di ba? Maasim po. Kaya pag sobra yung kinain mo, anong mangyari sa'yo? Sumasakit yung sikmura mo. May empatyo, heartburn, o di kaya hyperacidity. Right? And lahat nung nandito, 10.6, 11.5 cleaning materials. Yung tears daw 7.4. So basics, ibig sabihin. Ibig sabihin mapait. Kasi basic siya. So habang nag-ano ako, pakisolve to. So pakisolve, okay? Mag-ano lang ako na bilaukan. Okay. So, ang meron tayo, pH equals to negative log, H plus. Now, what if yung pH ang binigay, H plus yung kukunin natin? So, the relationship that you have there, when pH is given, H plus is just equals to 10 raised to the negative pH. Ganun din sa OH minus. 10 raised to the negative POH. So for this one, anong sagot dito? So we can, there's a certain rule that we need to follow, especially with significant figure. Now, for a pH value, ang significant figures mo ay yung number of digits after the decimal points. So how many number do you have after the decimal points here? Dalawa. So that means the final answer should be written as 1.5 times 10 to the negative 5. Yun yung rule. Gets ba?
Yes po, sir.
Now let's go here. Now this one, kukunin mo muna yung POH. Tapos kapag nakuha mo na yung POH, kukunin mo yung pH. Gamit yung relationship 14 is equals to the sum of POH and pH. So ano yung POH mo dito? 6 ba? You have two significant figures here. This is not a pH value. This is a number. So that means it is 6.60. So 14 minus 6, 6.60. What do you get? 7.40. Tama ba? Tama?
Yes
So
po.
these are the easy one and the sure one, okay? By next week, tapos na natin yung coverage yung third exam nyo. And unfortunately, I think they changed already the schedule. And I don't know if you like it. Alam niyo na ba yung may schedule? If I'm going to share to you. I just noticed it today. So yung third exam nyo, December 9. And your fourth exam will be during the finals week. I don't like it. You know why? Hindi kayo mag-enjoy ng holiday nyo. I don't know. You are the student. For me, I'm fine, but I always sympathize with the student. This week,
Totoo po, sir.
ha?
Totoo po, wala na po kami bakasyon.
This week, just to inform you, ano yung holiday this week dito sa US? So, this week, magsa-celebrate sila ng Thanksgiving. So, wala akong klase this week. Puro pa exam lang. But this week, because I told them, I rather do the exam before you leave rather than when you come back. Kasi sabi ko, magkakain kayo ng turkey, iniisip niyo yung exam niyo. That's why when I realized this one, binago na pala nila yung schedule. So, habang kumakain kayo nag-noche buena or nagpapaputok, hindi pa kayo tapos sa exam nyo. Which is unfortunate. I just learned it today. Okay? Ito ba yung tama? I just want to make sure. Wala, 22-23. Ito nga. So I'm sorry to let you know this. Okay? Because I was thinking, sabi ko, if it's November 18, when is the next exam? And I realized it's December 9. Tapos sabi ko, Pasko. And it just happened. It's January 4 to 11. Okay? Wala akong magagawa kasi departmental tayo eh. But I just like to let you know. Maybe spoil your day. Or maybe alam niyo na to sa ibang course, right? Anyway, let's go back. So, let's now go to the definition. Weak acid, weak base, strong acid, strong base. And if you're going to look at the materials that you have there in the module, meron silang discussion ng tinatawag na electrolyte. Okay? So, one definition of an electrolyte is strong electrolyte. So, when you have a strong electrolyte, this is the one that undergo 100% dissociation. This usually happen in ionic compound, like NaCl. Okay, so NaCl, when you put in water, they separate into cations and anions. So that's 100% dissociation. Now, another kind of strong electrolyte are the strong acid and strong base that we're going to discuss later on. Now, if you have a strong, you also have a weak electrolyte. Now, in a weak electrolyte, there's only a certain amount that dissociate, only a small percentage dissociate. Okay, and if you're going to look at the solution, the major component is still what we call the initial reactant that you have. So among the weak electrolyte are the weak acids and weak base. If you have acetic acid, it forms acetate and H+, but the major species is still acetate. Why? Because only a small amount of your acetate dissociate into ions. So this is the one that is related to strong acid and strong base. So ano pang kind ng non-electrolyte, electrolyte na hindi kasama dito? Yung hindi nagdi-dissociate. Yun yung tinatawag na non-electrolyte. Anong example ng non-electrolyte? Anyone? Give something. Or give an example of a non-electrolyte. Mga question, alam niyo naman. Which of the following is a strong electrolyte? Weak electrolyte or non-electrolyte? Okay. So the most basic example that we can have of non-electrolyte is what? Anyone?
Sugar.
Sugar. So when you have non-electrolyte, it will not dissociate. It will remain as is. So we will not cover the non-electrolyte because acids and bases, strong acids usually act as a strong electrolyte, weak acid and base are what we call weak electrolytes. Okay. Now, you need to know which is the strong acids and strong bases. That's all that you need to know. Because if they're not listed as strong acid or strong base, they can be considered weak acids or weak base. And later on, you will know why you need to know by heart which are the strong acids and which are the strong bases. Okay? So strong acids, they undergo 100% dissociation. There are 6, although 7 listed in one book or several books. You have 3 binary acids. So aside from HCl, you have what? HBr and HI. And these other 3, nitric, perchloric, and sulfuric. The 7th one is HClO3, chloric acid. So if you're going to look at the reaction that they have, as the arrow says there, it's one direction. So in solution, you don't have this. In solution, what you have is this acting as an acid. Because upon dissociation, wala ng HCl, wala ng HBr, wala ng HI. Ang nagkaroon na yung H plus or I minus or H3O plus, H plus plus H2O. So wala na yung mga initial na form ng strong acid. Now, weak acid is anything that is what? Not strong. So all you need to do, you know the 7, and anything that's not on the list are weak. And if you're going to look at this, it's a double direction arrow. So the major species that we have, they're usually the initial reactant. Now, ano naman yung tinatawag nating strong bases? So the strong bases are the soluble group 1A and 2A hydroxides. So all you need to do is what? You have a periodic table. And anything that is group 1A or group 2A and they have hydroxide, that is the strong bases. Klaro ba?
Yes po.
So these are the example, and all of them are what? Group 1A or group 2A. So if they're not listed there as strong bases, most likely, you know, as bases, they're weak. And again, the difference is in the arrow. Okay. Now you can apply whether you're strong acid or strong base or weak acid or weak base. The concept of the conjugate acid base are applied here. So what do you need to know? The conjugate base of a strong acid has no measurable strength. So what does it mean? All one direction arrow. I'm trying to look at it like this one. So any of the ion here, they don't have strength. Okay. Why do they have no strength? Because they cannot go to the backward reaction. It's almost one direction. So if you're strong on this side, you're weak. Your conjugate acid and conjugate base are weak on this one. But if you're weak on this side, you're strong on the other side. Your conjugate acid or base will be stronger. Okay? Nasa na yung statement na yun. H2O plus is the strongest acid that can exist in aqueous solution. Does that make sense? Hindi HCl o hindi HR o hindi doon sa 7 strong acid ang strongest acid. Bakit? Look at the reaction. When you put them in water, these species don't exist anymore. Ano na yung form na nag-exist? Once they dissociate. The H2O plus. That's what the statement means. Hindi HCl, hindi HNO3, hindi HClO4, yung strongest acid sa solution. Ang strongest acid sa aqueous solution ay yung HCO plus because this one don't exist anymore once they become part of the solution. I will show you a drawing later on what does it mean kung hindi nyo pa magets ngayon. Okay? And the OH are also the strongest base that can exist because in the end, wala na mga to. They dissociate 100% to give the hydroxide. Okay? Now, if you're going to look at the strong acids here on this side, their conjugate base are weak. So the weaker acids here, they have a stronger conjugate base. So ito yung sinasabi ko, kapag strong ka sa left side, yung conjugate base mo ay weak. Kapag weak ka sa left side, doon sa right side, yung conjugate mo, base mo, stronger. Okay? So this is what I told you. So when you have a strong acid, initially what you have? Lahat HCl. But once they form in the solution, it's either HCl, H plus or Cl minus. You don't have any HCl. Kaya yung H plus or HCO plus, that's the strongest acid in the aqueous solution. Gets better?
Yes po.
Now, compare it with the weak acid. Pag nasa solution siya, ano yung major species? Yung pa rin weak acid. The H plus and the F minus is just what? Minor species because only small amount dissociate. Yan yung difference ng strong acid saka sa weak acid. Okay? Question? So let's try to solve now pH of strong acid, strong base, weak acid, and weak base. Now, pH of strong acids and strong base, they're really what we call straightforward. You just use what? pH equals to negative log H plus. So whatever the initial concentration, usually yun din yung concentration ng H plus mo. Because they undergo 100% dissociation, right? So if you have this, they will form what? In water, they will form H3O plus and NO3 minus. So if you have that, that is also the amount that you're going to form. And all you need to do is what? pH equals to negative log 2 times 10 to the negative 3. And that is equals to what? Is it 3? Because if it's pH, that means point something. Remember, the pH, the significant figures is after the decimal. So this is equals to 2.7. So there's only one significant figure, so you be one place after the decimal. Now, how about this one? It's 2.7. The answer is 2.7. Because isa lang yan, no? So that means after the decimal, isa lang. So kapag 2.0 yan, edi 2.69 yan kasi dalawa. Clear ba yun? So what is the pH of 1.8 times 10 to the negative 2? So you have what we call the barium hydroxide here. So it dissociates to give you barium 2 plus and 2OH minus. So 1.8 times 10 to the negative 2, 1.8 times 10 to the negative 2, and then 2 times 1.8 times 10 to the negative 2, which is equals to 3.6 times 10 to the negative 2. So you have POH, negative log, 3.6 times 10 to the negative 2. So that is equals to what? $1.74, but you're not done there. What is being asked? The pH. So that means 14 minus 1.74, giving you, ano yan, 12.26. Ano yung sagot? Baka mali yung sagot ko. 1.44? Kasi may nag-ano na 174 eh. So if that's the case, this is now 12.56. I just follow what you answer kasi wala akong calcu eh. So kaya ba? Strong acid, strong base?
Yes po.
Eto, punta tayo sa complicated. Why is it complicated? Because it doesn't undergo 100% dissociation. So kung ano yung initial concentration, hindi yun yung concentration ng H+. Okay? So what you do is, usually, if you have a weak acid, meron kayong tinatawag na constant. So if it's HA producing H plus and A minus, or that one, if you're going to write the equilibrium expression for that, since this is an acid, we call it the Ka. So Ka is equals to products over products of the reactant. So in this case, ang tawag natin sa Ka ay acid ionization constant. And if we're going to look at the value of that, it's so small. Now, what do you think is the value of Ka if it's a one direction? Usually, it's so high because karamihan, product. Wala masyadong natitirang reactant. Now, the presence of the Ka is just one way for you to tell yourself that, oh, this is a weak acid. Because only weak acid has Ka value. Anong basis ng Ka? Anong information yung kino-convey ng Ka? Usually, the higher the Ka value, the stronger is the weak acid. So if I'm going to ask you here, which is stronger? Formic acid or acetic acid? Ano yung sagot nyo? Sige nga, type nyo. Style sa inyo. Sino unang nag-type? Susundin yung sagot doon. So if you're going to look at this one has a higher value compared to that one. So formic acid is a stronger acid than acetic acid. Now, paano yung tanong? Ang given lang sa inyo is Ka. Which conjugate base is stronger? Is it the formate or the acetate? Wrong. So usually, ang relationship ng Ka and Kb, if you multiply them, Ka times Kb is equals to Kw. So if you have the Ka and the Kw, you can determine the Kb. So Kw is equals to Ka. So usually, kapag mas mataas yung Ka mo, yung Kb mo ay ano? Mababa. Okay? So if you're asked which is the stronger conjugate base, the answer is the acetate. And if you're going to look at the value, look, 5.6 times 10 to the negative 10, yung isa, 5.9 times 10 to the negative 11. So expect questions like that. Not pretty straightforward, pero should know the relationship. Question. Remember, yung coverage ng exam 3 ninyo, itong tatlong topic lang sa isang module. They're all equilibria. Almost half ng Gen Chem 2 na tinuturuan ko. It's all about that K. Ang role nga nyo is to be DO. Where to place DO, before or after K. So let's solve weak acid pH problem. So what is the pH of 0.5 molar HF? So maybe it's a pretty straightforward there. And I can assure you, if it is a multiple choice question, one of the answer that you have there is the one that will give you this. But is that the right answer? Tama ba to solve this is pH is equals to negative log 0.5 plus kailan na magiging tama ang sagot sa question na ganito? It will only be correct if
Nakasolve po with significant figures.
no, if this is a strong acid. Yes. But it's not a strong acid, so hindi siya ragato pwede. So how do we solve that thing? So we're going to write the reaction. HF reacting with water, producing H3O plus and F minus. So you have here what? 0.5 initial. Remember the rice equation or the ice? You have 0, and then what do you have? Changes here, minus X, plus x, and then you have here equilibrium, bringing down everything. And then Ka is equals to H3O plus or H plus times F minus over HF. So Ka value of this should be given. So we get it from here 1.7 times 10 to the, no, not, it's hydrofluoric, 7.1 times 10 to the negative 4. And then you replace it there. Now, what is good about here? You can make an approximation. What's that approximation? That the x value is so small that if you put 0.5 minus x, it's just equals to what? 0.5. And when that happened, everything is simplified. So 7.1 times 10 to the negative 4 times 0.5 equals to x squared. And then you can just solve for x, which is just the square root of this. So yung tinatawag natin approximation, let's say you're Donald Trump. Sabi niya, bilyonaryo siya. Kapag nawalan ka ng $1, bilyonaryo ka pa rin. Eh yun kung totoo nga bilyonaryo siya. Because the $1 that you lose is so small compared to the billions of dollars that you have. May limitation yan, and I will tell you what it is. So what is x? X here is also your H3O plus. So ano yung value ng x na nakuha mo after you do the operation? Sige nga. Anyone? So 0.019. Now, what is negative log 0.019 equal to? Negative log of what? Maybe gawin na natin 0.50 to, just in case. Okay? So this is equals to what? 1.72. Now, the question is, how do we check if our approximation is right? So this rule only applies if the percentage dissociation is less than 5%. So if we're going to look at the percentage dissociation or ionization, so that's just your H plus over your HA times 100. So what is your H plus? 0.019. What is HA? 0.5. So times 100, ilang percent? Yeah. It's 3.8%. So that means that approximation is valid. Yun yung ibig sabihin nun. Okay? So So di ba mas easy? Now you might ask, Sir Meng, paano po pag more than 5%? Di mag-quadratic formula kayo. You have to arrange it in an ax squared plus bx plus c equals to 0. Tapos gamitin yung quadratic formula to determine x. Now let's what we call the rules that we have in solving weak acid ionization problems. This can also be applied with weak base. Ang difference lang yung weak acid H plus sa weak base OH minus. Okay? So in weak acid, pag nakuha mo yung H plus, kukunin mo yung pH. Sa weak base, kukunin mo yung OH minus, kukunin mo yung POH, and then subtract mo sa 14 para maging pH. Yun yung difference ng dalawa. So you have to identify the major species that affect the pH. So usually kung ano yung given weak acid or weak base. In most cases, you can ignore the autoionization of water. You ignore the hydroxide because it is determined by the H plus. And then you use the ice to express the equilibrium concentration in terms of single unknown X. Yung ginawa natin. And then write Ka in terms of equilibrium concentration. You can use approximation method. If it's not valid, then use solve for X exactly using the quadratic formula. And then you calculate the concentrations of all species, especially the one that will give you the pH. Try natin another one. This one, 0.122 monoprotic acid with Ka 5.7 times 10 to the negative 2. So you have an HA producing H plus and A minus. So you have what? 0.122, 0, minus X plus X plus X, 0.122 minus X, and X. Ka equals to H plus, A minus, HA. Then you put the value. And then what? X times X over 0.122 minus X, which you can do an approximation. So what do you get here? X squared equals to 5.7 times 10 to the negative 4 times 0.122. Then you get the square root. Ano yung X? X is equals to H plus. What is the X value? .024 ba? So it's 0.083. And if that's the one, what is the log? .083 or 0.0083? I think it's 8.3. And that is equals to what? pH. Excuse me. 2.08. Now we have to check, right? So 0.083 or 0.83 divided by 0.122 times 100, that is equals to what? If it's less or more than 5%. 6.8%. So it's a little bit higher than 5. Now, if we're going to do quadratic formula, ano ko na straight sa inyo, ang makukuha mong x sa quadratic formula is 0.0081. So, anong equals dun sa pH? Ano yung negative log of tatlong ano, yeah, 0.0081. Ano yung pH niya? .09. So, konti lang yung difference kasi konti lang yung agwat niya doon sa 5%. So again, the percent ionization, kung ano yung concentration ng hydrogen ion divided by the initial concentration times 100. And if we're going to look at the difference between a strong acid and a weak acid in terms of percent ionization, so as you could see, strong acid always 100%. Weak acid, look at this. What do you think happened? The more diluted, ano yung effect doon sa percent ionization? Sige nga, kung kaya nyo mag-interpret ng plot or ng graph. The more diluted, higher or lower percent ionization? Mas mataas ba ang ionization or mas mababa pag diluted yung sample? Yun yung question dyan. Baka may mga tanong dito, yung mga concept question. So, the more diluted your sample, if you're going to look at this, saan banda part yan, yung more diluted dito sa graph? Saan yung mas diluted dito? Look at the concentration there. So, the more diluted your sample, that's the one here. The higher is the percent ionization. The more concentrated it is, the less ionization. Ito yung mas concentrated. Look, going up here. Analyze to convince yourself. Hindi porket sinabi ko, maniniwala na kayo. So the more diluted that you have, that means you go here. So the more diluted that you have, the higher is the ionization. Kita nyo? The more concentrated goes there. And the more concentrated, mas mababa yung percent ionization. Gets ba? Hello? Hello, hello.
Yes po.
Now, the last part that we have, base. So how does the reaction with base? It's similar to the weak acid, but instead of Ka, you have Kb. So pag Ka H plus, pag Kb OH minus. And again, the relationship of Kb, the higher the Kb, the stronger is the weak base. So you solve weak base problem like weak acid, except you solve for OH instead of H plus. So the sample that I have here, I'll just use this one. So what if the initial concentration of this is 0.4 molar? So what is the pH? Given the Ka or Kb, not Ka. If you're going to look at the Kb of ammonia here, 1.8 times 10 to the negative 5. So paano natin isa-solve? So we could use what we do, 1.8 times 10 to the negative 5, and then what? X 0.4 minus X, and then we could say it's just equals to 0.4. So 1.8 times 10 to the negative 5 times 0.4. So you have what? X squared. So you get the square root of that. So ano yung X value? That is your hydroxide. So ano yung nakuha mo? Wala kasi yung calculator ko eh. That what you get? 2.7 times 10 to the negative 3. So you have to get the negative log of that. That is equals to what? The POH. Ano yung sagot? $2.57? Is that the final answer? No, because that's the POH. So the answer would be Kaya? Kaya ba?
Yes po.
Carry naman po. Kailangan i-carry. Now let's go to the last part of our lesson for today, yung buffer. But before we talk about buffer directly, we go to one concept that we have discussed doon sa chemical equilibrium, yung effect ng stress, yung so-called common ion effect. So whenever we have a common ion effect, there's a shift in the equilibrium caused by the addition of a compound having an ion in common with the dissolved substance. So for instance, kapag meron kang common ion, yun yung dinagdag mo sa product, tapos ang mangyayari, pinifavor niya yung backward reaction. So when that happens, it suppresses the ionization of the weak acid or weak base. So for instance, here, you have sodium acetate and sodium acetate and acetic acid. So ito yung nangyayari dito. So ano yung common sa kanila? Anong ion yung common sa dalawa? Ito. So yung presence ng common ion na yan, magpe-favor sa backward reaction. So it's going to push the reaction backward. Okay? Now, try to consider if you have a solution or a mixture of salt, NaA, and HA. So ito yung reaction nila. So ano yung common dito? Ito. Now look at the reaction. This is double direction, this one is one direction. So that means ito mangyayari to. They have a salt, so it will dissociate 100%. So the presence of this will force this reaction, this ion to go up, forcing the reaction to be this. And as you could see, it's a Ka relationship. So ano nga yung mangyayari dito? Okay, so you want to determine, okay, ano mangyayari sa pH na to? So maybe you want to isolate H plus on one side, so you multiply both sides by HA over A minus. Now you might say, why? Because you want to eliminate that. So if you do it on this side, you have to do it on this side also. And what do you have there? Isolate yung H plus. Tapos dito KAHA over A minus. And then what will happen? You can get the negative log of this, the negative log of Ka, and then the negative log of HA over A minus. So ano yung negative log of H plus? Anyone?
pH.
pH. So ano itong negative log of Ka? So you follow the same principle doon sa negative log H plus at negative log OH. So this is your P, Ka. Remember, negative log of H plus is pH, negative log of OH is POH. So kapag Ka naman, negative log, so pKa siya. And this one will remain like this. Now, ano mangyayari kapag binaligtad ko itong dalawa? What's the major changes? Pag binaligtad ko yan, magpabaliktad yung sign dito. From negative, magiging positive. And this is what we call the Henderson-Hasselbalch equation. One of the most useful equation. And if you're going to look at the Henderson-Hasselbalch equation, makikita mo dito, itong A minus ay ano? Conjugate base nung HA. Right? Now, anong mangyayari kapag yung concentration ng conjugate acid mo at conjugate base ay pareho? Your pH is just equals to your what? pKa. Kasi ang mangyayari, that will become log 1. And log 1 is equals to, anyone? Log of 1 is equals to what?
Zero.
Okay, so magiging 0 yan. So if that's the case, when the concentration of your acid and conjugate base are the same, the pH is just equals to the pKa. So yung Henderson-Hasselbalch equation na yan, ginagamit niyan doon sa tinatawag nating buffer solution. So a buffer solution is either made up of what? A weak acid or a weak base and its conjugate base or conjugate acid that comes from the salt. Look at what happened, our example that we have so far here. Weak acid, and then conjugate base yan. CH3 COO minus that comes from CH3 COO Na, which is the salt. Now, what do buffer do? They resist drastic pH change. They neutralize any added acid or base. How? By looking at the reaction. So if ever you have equal molar of acetic acid and sodium acetate, if you add strong acid, what will react with it? The conjugate base producing the acid. If you add a base, the one that will react with it is the weak acid producing its conjugate base. Ito yung mechanism ng buffer. Now, what's the question that can be asked for you here? Classic question. Okay, or before we go that, so if you want to see how the buffer works out, so if you have HCl, it dissociates to H plus and Cl minus. So if you don't have a buffer, the presence of the H plus here will result in a drop on the pH value. But if you have a buffer, so the HCl will release what? H plus that will react with this one to produce this and Cl minus. So there's no drastic change in the pH. So ito yung graphical way of what is happening in the buffer. Now, classical question na matatanong dito are this one. Kaya niyong sagutin. Can you consider A as a buffer? So anong kailangan nyo sa buffer? Weak acid or weak base? So it's useful here to use the definition of a strong acid and strong base. Kung alam niyo yung strong acid, strong base, so anything that's not included there are weak acid or weak base. So is letter A a buffer? Is it a buffer? Yes, it is a buffer. Because HF is a weak acid and F minus is its conjugate base. And you have HF, F minus from KF, which is a salt. Claro? Now, how about the second? Is a weak acid or weak base? Well, weak acid. Is it a buffer?
No po.
How about the others? So if you're going to look at is HBr, you classify HBr as a strong acid, so it's not a buffer. How about this one? So ano yung acid dito? So maybe this dissociate to give you what? HCO3 minus, and its conjugate base is CO3 2 minus, which is that one. So this is what? A weak acid. So this is a buffer. Expected na yan, class. You're going to have a question, which of the following is a buffer? Or is this a buffer or not? So A and C are buffer, B is not. Question, before we go to the last one, although sabi nila, hindi daw magtatanong ng calculation, but I just want to show you some simple calculation on a buffer. And you just use Henderson-Hasselbalch equation and identify which is the acidic and the basic component. So question, in identifying a buffer, We almost have what, 5 minutes left? So the last one that we have, just follow the first statement. Wag na sagutin to. To calculate the pH of 0.30 ammonia and 0.36 molar ammonium chloride vapor system, and I'm going to give you the pKa as equals to, and then pKa, 9 point something, 9.25. So it's just a Henderson-Hasselbalch equation. So pH is equals to pKa plus log base over acid. So what's the common mistakes here? Students cannot identify which is the base and which is the acid. So I can put 9.25 here, but which 0.30 something will I put in the numerator and the denominator? Sige nga. 50% chance. Ano yung sa taas? 6 or 0 after 3? Yes? Tama ka? So ano yung nasa taas? Now you may ask yourself, paano po namin malalaman alin yung acid, alin yung base? So an acid is always what? One more hydrogen than the base. So you have an NH3 and an NH4 plus. So this one is 0.30 and this one is 0.36. So ano yung sagot? Ba, 23 lang kayo ah. So the answer is 9.17. Now, I will end this session here. Now, next meeting, we might finish the module 6 and start with module 7. But you have to prepare, kapag nakita ko less than 25 yung class, I'm going to give a short quiz. Okay? Kasi 24 lang eh. So kapag less than yan, magbibigay ako. Gagamitin ko, let's say, 5 minutes of the time to give the quiz. So before I leave, I'm just going to make your grades available. I always do it at the end para pag nag-disappoint kayo, makikinig pa rin kayo. I mean, I don't do it at the beginning because kapag nag-disappoint kayo, hindi na kayo makikinig sa lecture ko. So, nego signal na. Chem 18, second lecture. Post, where is that one? Ano ba section ito? Raise.